Hi everyone, it's Mr. Morrissey. We're looking at completing the square today. We're looking to be able to transform a quadratic equation into the form x minus p squared equals q. We've also proved the quadratic formula. What I have in yellow I think will become more clear after we do a couple of problems with completing the square. We're only doing a total of 3 problems, and I think this is going to be pretty straightforward, and you're going to see that really completing the square is a great way to transform an equation into vertex form. So let's see. It says solve this equation by factoring and completing the square. Well, factoring we've already done, so let's do that first. So the factors of 12 probably are going to be 4 and 3. I think. Might not be right. Let's see. Seems like x minus 3, x plus 4. I want to make sure everyone knows that this x minus 3, I wrote very quickly x equals 3, but I assume everyone knows that you take the entire term and set the entire term equal to 0, and then solve for x, which gives you 3. So I've just actually solved this problem, and I've gotten negative 4 and 3 for my answer, but now I want to do the harder work of doing the completing the square, and here's the deal with completing the square. You take the b term and add b over 2 squared to both sides of the equation. Okay, so if we add b over 2 squared to both sides of the equation, we are going to complete the square. So before filling in this chart, let's actually do the completing the square. So that's what our objective is saying. So I'm going to take, whoops, nope, I'm going to redo that one. Hold on. I always do that in class. So I'm going to take, hold on. I'm going to take the equation, and I'm going to actually put the 12 to the other side, because that's the form that the objective said to get it into. And I know that there's an invisible 1 in front of the x, and so the b term is 1. So b over 2 squared equals, that equals 1/4. So we're going to add 1/4. So we're going to add 1/4 to both sides of the equation. Welcome. So plus 1/4 plus 1/4. As long as you add 1/4 to both sides of the equation, nothing has changed about the equation. You've just put it into a different form. Now, if we factor, 12 plus 1/4 is 12 and 1/4. And let's see. So if I take the square root of 1/4, I'm going to get 1/2. It seems like it's x plus 1/2, x plus 1/2. If you wanted to expand out x plus 1/2 times x plus 1/2, you will go back to the x squared plus 1x plus 1/4. So here, I think, is my almost ready to go vertex form. Right there, that's what the objective said to do. Solve for the, I think it was x plus q, or x plus p squared equals q. We just did that. Using square roots, we could square root both sides, and we could solve. So let's solve this 2 different ways. I like to solve things, if we can, side by side 2 different ways. I think this is a cool thing. So if I square both sides, make sure you guys remember plus or minus. So remember, we already factored this, so we should get the same answer. I can't recall off the top of my head. I'm looking at my notes. Negative 4 and 3 we got. So let's make sure this is negative 4 and 3. So that's 6 over 2. Yes, that's 3. And the second one There's the -4, guys. So we just know that it worked. So adding, I think it was 1/4 to both sides, that worked. So our two roots are 3 and -4. So this was solving with square roots. Um, I guess that's how you do it. So if I wanted to write the equation in vertex form, I guess that was another thing we could do. The vertex form equation is this. Done. So let's see, guys. Let's go back up to that chart just to illustrate what the heck this completing the square actually is in a visual. So if I break up x squared into x, oh gosh, if I break it up into x, hold on, into x and x, and then if I take the b term, so the b term, if I cut it in half, so the b term, the b equals 1. So if I take 1 and divide that by 2, I get 1/2, 1/2. I'm just going to make it a little bit bigger. If I fill in all the boxes on this chart, I get x squared, 1/2 x, 1/2 x. And so x squared plus 1/2 x plus 1/2 x is x squared plus x. The final part in the square that hasn't been added is 1/2 times 1/2, which is 1/4. So to complete the square, to fill in the empty, to fill in the missing piece, you have to add 1/4 to both sides. That 1/4 that gets added to both sides is the b over 2 squared part. So to review or summarize, completing the square is a great way to solve a quadratic, and even better way to get to transform a quadratic into vertex form. Let's do another one. Number 2. Complete the square to solve a quadratic equation. Okay, I have it already set up into the form that the Common Core likes to talk about. So it looks like b is 8. Just to be absolutely sure, a is 1 and c is -14. But you're not going to need c and you're not going to need a. So let's take b over 2 and square it. So don't do anything in your head because you're going to be apt to make a mistake, I think. So it looks like you're adding 16 to both sides. So let's write that down. Add 16 to both sides. So if we add 16 to both sides, let's transform this, okay? I'm going to see if I can color code this to make it clear. And I'm really trying really hard to go slowly. You can see my voice is a little bit hoarse. I'm going to have some tea right here. My doctor recommended something called throat coat, which I got at Whole Foods. And it's like, it's good if you have like a sore throat, I guess. Throat coat. It's by Traditional Medicinals. It's pretty good. So let's see. I'm adding 16 to both sides. So x squared plus 8x, and now plus 16 equals 14 plus 16. Again, if you add the same thing to both sides of the equation, nothing's changed. You could always just subtract out the 16 and go back to where you started. Okay? Someone's actually playing a ukulele in the room. Is that a ukulele? Do you guys know in Hawaii, I guess apparently ukulele is a huge business. I saw something on the news about it. It's really cool. Yeah. Anyway, sorry, I got to get back to focus here. So let's see. So this is going to be x plus 4 squared equals 30. That's almost in the proper form. So next, okay, so what did it say to do? Solve. So we actually want to take the square root of both sides. So I want to put this in the right form. So I want to have the a first. So I want to have, So negative 4 plus or minus root 30. That's going to be my answer. And yeah, so I've just solved this quadratic. If you had thrown it into the quadratic formula, you would have gotten the exact same answer. Okay, last one. This last one's going to seem sort of overwhelming, but it's going to be okay. We're going to prove the quadratic formula, which is something that the Common Core, the new national standards for mathematics, is suggesting, or basically saying that students should have exposure to. So prove that the roots of ax squared plus bx plus c are the quadratic formula. Okay, so first things first, when we complete the square, the a term has to be 1. So I'm going to start out like this, okay? And I know with the quadratic formula, we're finding the roots. So when you find the roots, the y term is always 0. This is going to take us some time to do. So remember, if I was to throw in a quadratic, keep in mind the two roots that the quadratic formulas are finding are the number comma 0. Or I should say even better, the root comma 0. So the comma 0 is why I have a y equals 0. I'm going to divide by a to get the x squared term to just have a 1 in front of it. So x squared plus b over a plus c over a. Now I'm going to complete the square like we did on the last two problems. Okay? So this is going to take a second. So I'm going to move the negative c over a to the other side. I left out an x. Okay? So let's do the b over 2 squared part. So b over 2 squared. That's going to equal b over a. Now dividing by 2, you can just pop the 2 right next to the a, and then square. That's b squared over 4a squared. So b squared over 4a squared is going to be added to both sides. So let's write that in different colors. So all I did was add b squared over 4ac to both sides of the equation. Okay, and so now, so look, it looks like it's a complicated mess, but I'm just going to complete the square on the right-hand side. Okay, so let's complete this square here, or I should say, let's just sort of, let's factor this. So you know it's going to be something squared. So x plus, all you do, guys, is take the square root of the last term. So I'm gonna highlight it. So take the square root of b squared over 4ac. You can do that in your head. So the square root is going to be b over 2a. And that's going to equal, am I recording? Yep. So negative c plus b squared over 4a squared. Okay, so now you're thinking like, okay, we're stuck. We're trying to get to the quadratic formula, and we can't figure this out. Well, on the left-hand side, we want to get a common denominator. The common denominator on the left-hand side is 4a squared. I'm going to rewrite this. If I was to multiply by 4a, okay, I'm going to verify that's right. So cancel, that would be negative c over a, perfect. You guys see how this is sort of materializing into the quadratic formula? So I'm going to get the common denominator in the left-hand side to be, there's b squared minus 4ac. That's the discriminant in the quadratic formula. Okay? So there is my equation. And now I'm just going to square root both sides like we did in the last two questions. So when I do that, almost done, guys. We have like maybe 3 more lines of work. So we're going to have plus or minus square root, there's the discriminant, and then divided by the square root of 4a squared. Okay, and so when I simplify this down, I get that's the quadratic formula. You can see the common denominator is 2a. So let's write it how it appears at the top of your paper. Okay, we spent a lot of time on this. I want to make this look really nice. So, ta-da-da-da, yay! So I just need a sticker to put on there. So we got the quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a. We are good to go. Thanks, guys.